Let's go over solving systems of linear equations problems. Now these are worth 40 points on the SAT, so this is a concept you're definitely going to want to know. So our approach to these questions is going to be to identify solving systems of linear equations questions. We're going to create and analyze a system of equations. We're going to create a formula to solve these equations, and then we're going to solve a practice question. So how are you going to identify this concept? Well, they're generally going to show up as two linear equations. And they're most likely going to ask you to solve for x or y. But definitely read these questions carefully because sometimes they'll ask you for x plus y or x plus 3 or some combination of something that isn't just x or y. And they'll put just x or just y as an answer choice to confuse you. So make sure you're reading these carefully. So here's the formula we're going to follow for solving system of linear equations questions on the SAT. We're going to analyze our two equations. We're going to write down what the question is looking for, and then we're going to use substitution or elimination or Desmos to find your intersection point if you have one. So intersection point is the same thing as a solution. We're going to find one of those. And the reason I say if you have one is because sometimes it'll test parallel lines, which are lines that look like that and will never intersect, so you'll never have a solution. So here's a practice problem. Let's look at it. It says given the equations 3x plus 2y equals 8 and 2x minus y equals 3, what is the value of x plus y? So I'm going to analyze our two equations. I can see they're linear because we have our x and y in both of them, and we have no squared signs or anything of that sort. And I'm going to write down next what the question is looking for. So this is where a lot of kids get tricked. They just find x or y, but we're looking for x plus y. So I'm going to just write up here, looking for x plus y. And just writing this down helps me not forget this when I'm working the actual question. Okay, so let's use this information to find our answer. So I'm going to start by rewriting our second equation, and I'm going to use substitution for this question. So here's our second equation, and I'm going to isolate y so we can substitute it into the first equation. So first, let's subtract 2x from both sides. And then we're going to multiply both sides by -1, and this is going to give us y equals 2x minus 3. So now that we have our y isolated, we can plug it into our first equation. 2 times 2x minus 3, and this is going to equal 8. Now let's write the next step of this after we multiply out this 2. And our final step here is going to be 7x equals 14, and x equals 2. Okay, so we have x equals 2. Now don't get tempted by b here, because we're not looking for x. So let's find y now. And I'm going to find y just by plugging it into this equation right here, plugging x into this equation. So y equals 2 times 2 minus 3, y equals 1. So let's refer back to what we were actually looking for. And what we're looking for, as we found earlier, is x plus y. So I'm going to do x, which is 2, plus 1, which is y, and our answer here is 3. C is correct. So this is a concept where Desmos shortcuts are going to be your best friend. And the reason for that is because you can plug in both equations to Desmos, and then plugging in those equations, you can find intersection points, and it's a lot quicker and honestly a foolproof way to do these questions. So let's move over to Desmos. Here in Desmos, I've plotted both of the equations of the problem we just did. And instead of doing all that messy elimination or substitution math, I can just click on this point where it looks like they intersect, and it's telling me that point is 2, 1. And so that's our x and our y. x2, y1. We could just add them together and boom, we have our answer of 3. So for this concept, Desmos is a must use, whether it's doing the entire problem like I just showed here, or if you like doing substitution or elimination, do that and then check your answer in Desmos. But either way, how you approach this problem, you're definitely going to want to use Desmos. So good luck.